Good afternoon. Welcome to the good afternoon. Yes, yes. Hi guys, am I audible?
इधर करता है नहीं मगर
Hello, can you guys hear me? We'll start the session. Okay. So in the previous session, we learned about the different types of drones, and we focused on a specific type of drone known as a multi-rotor. And in this session, today's session, we'll be learning about the different parts of the multi-rotor and how they work together. And while I go through each part, I would like you guys to note down each and every part as I go through it, so that when you are building, it will be easier for you. Okay, so let's start with the first part, which will be either the frame or it will be the propeller. While building a drone like a multi-rotor, you can either start with the frame first or the propeller. Propeller is the spinning blade, that is the fan. Now, in this case, I'll start with the frame first. So frame is the body of the multi-rotor, which will house all the different parts. When you are building a multi-rotor, the first thing you should do is keep the application in mind. Think about why you are building the drone. Are you going to fly indoors or are you going to fly outdoors? Or is the drone going to carry something big like a professional camera or maybe a tank of water? And depending on that application, the size of the frame will change. For example, if you are building the drone to be flown indoors, then the frame will be smaller. It will be something like this, or maybe something like this. If you are building something big, then the frame size will be quite large. The frame, when you go to buy, you can identify the size by looking at the sizes given in mm's. So for example, if a small frame has a given size of 90 it means that the diagonal motor to motor distance is 90 So can you guys see the drone that I'm showing you? You can reply in the chat or unmute and reply.
yes.
Okay. So from this end to this end, this is a 85 drone. So from this end to this end, the size is 85 When you go to buy a frame like this, it will be mentioned that this frame is of size 85 And I have another example, that is this one. So this is a 250 drone. So from this end to this end, the distance is 250 This is one way you can identify the size of a drone. And second way is the propeller size. The maximum propeller size that the drone will support. It will be mentioned on the frame. For example, this one here will support a maximum propeller of size 5 inches. So this one is a 5-inch propeller. And as you can see, it fits perfectly on this frame. Okay. The next thing is depending on the application. If you are building it to fly indoors, the drone might have like guards on the frame, like the one I just showed you. The small drone has protectors on the side of the propellers that will protect both the person, the people who are around the drone, and also the drone itself in case of a crash. Next, there will be a requirement. If the drone is going to carry something big, then you might want to add more motors to the drone. The drones that I showed you are called as quadcopters because they have 4 motors. You also have the option of adding more motors. So you can have 6 motors, you can have 8, you can also have 10. You can also have a lesser number of motors, that is 3 or 2. But the lesser the number of motors, it becomes quite complicated to control the drone and build the drone. Deepak, the video I am not showing at the moment. So whenever required, I'll turn it on. Okay, so next part is when you buy a frame, you have the option of either buying the frame or you can build the frame yourself. Then the choice is of the material you want to buy. The most common material you get is carbon fiber. This frame here is made up of carbon fiber. This is a both strong and lightweight material and most commonly used for drone frames. Whenever you go to buy on online websites, this will be the most common material that you will find. Although it is expensive than the other materials that I'm going to show you, it is the stronger and lightweight. The other materials that can be used are maybe wood. You can use plastic. For smaller drones you can use plastic, but plastic is brittle, it might easily break in crashes, while carbon fiber is quite hard. You can also use fiberglass. Fiberglass is also stronger than plastic but weaker than carbon fiber. There is another material which you can use is aluminum. So aluminum is both strong and lightweight, just like carbon fiber, but in case of a crash it will bend. But as compared to carbon fiber, aluminum is slightly heavier. A good thing about aluminum is that it is readily available in the market and it is much more cheaper also as compared to carbon fiber. So what the common practice is that whenever you are building a prototype of a drone, you will first go for a aluminum frame. Then once after testing is completed, the final product, you can move on to a carbon fiber frame. Now you can also use wood, but wood, any stiff material you can use to build a frame. But the most common thing that people do is buy a frame because they are readily available on online stores. And the links to the online stores I'll be sharing you at the end of the session. So up till now, if you guys have any questions about frames, any doubts you want to ask, you can ask now. You can either use the chat or unmute yourself and ask. And the people who miss the beginning part, you can get it on YouTube. It is streamed live on YouTube, so you can watch the starting part there if you missed it. Okay, so first part in the drone building list will be a frame. So if you guys are maintaining a list, that will be the first part, frame. Maintaining the list will make it easier for you to create as a checklist. It will be easier for you when you are building your own drone. So if there are no questions, I'll move on to the next part. Okay, so shall I move on or you guys have questions? Please reply. Okay, then I'll move on to the next part since there are no questions.
So no questions.
Okay. So next we will look at the propeller. Propeller is the blade that you see on top of the motor, which is the spinning blade, and it pushes the air down. Now propellers are designed to spin in a particular direction. Like in the previous session, I told you guys that two propellers spin in clockwise direction while other two propellers spin in counterclockwise direction. So this is to compensate the torque in particular directions, and the opposite spinning propellers counteract each other, keeping the drone stable. Now, since the propellers are designed to spin in a particular direction, that is either clockwise or counterclockwise, whenever you are buying a propeller, you must make sure that you're buying them in pairs, and two two pairs of propellers in case of a quadcopter, and two of them should be counterclockwise, two of them should be clockwise. Now, how to identify a propeller, whether it is clockwise or counterclockwise? Okay. So here, as you can see, this here is a clockwise spinning propeller, and this is a counterclockwise spinning propeller. A propeller spins in the direction of the leading edge. So leading edge is the one that is pointing upwards. As you can see, towards the clockwise side, this is the upper part, and the propeller will be spinning in this way. And you must make sure that the counterclockwise spinning propeller is correctly mounted on the counterclockwise spinning motor. Otherwise, the drone will not take off. Next is the propeller size. Like in the first part, frames, we can either start with the selecting the frame first or the propeller by deciding the size of the propellers, and then you can move on to selecting the frame. Now, depending on the purpose, you will either build a smaller drone or a bigger drone. You will need smaller propellers or bigger propellers. Propellers can be as small as like a few mm in size, 2 inches, 3 inches, 5 inches, and even as large as 33 inches big. The inches that I'm talking about. So here, this is a 5-inch propeller. When the propeller spins, it creates a disc. This disc here is the diameter of 5 inch. The disc that is formed when the propeller spins creates a disc of 5 inch. That is why this propeller is called as a 5-inch propeller. The next thing is the pitch of the propeller. Pitch is the distance the propeller can travel in one complete rotation. So imagine if the propeller is not attached to a motor and it is spinning, somehow it is spinning in midair. So in complete one rotation, it will travel a particular distance. That is called as the pitch. Now, bigger the propeller, whether in size or pitch, it will be heavier. And when you mount it on a motor, it will require more thrust to spin that particular propeller. Since the propeller has more surface area, because it is bigger, it will produce more thrust, but it will also have more drag. Drag is the friction that is produced by opposing the motion of air. The next thing is the number of blades on a propeller. So as you can see in the PowerPoint presentation picture here, this is a 3-bladed propeller. It has 3 blades. There are also 2-bladed propellers and even 4-bladed. So here I have a 4-bladed propeller. And I also have a 2-bladed here. So this is how a 2-bladed propeller looks like. Now, just like the size of a propeller, as the size increases, the surface area increases. Just like that, the number of blades, when they increase on a propeller, they will produce more thrust, but it will also increase the surface area, causing more friction, air friction. And hence, it will also require more thrust, more drag. It will create more drag, and the motor will require more torque to spin the blade. Hence, as a result, it will draw more current. So more number of blades are usually preferred when a more gripping of the air is required. In case of racing drones, for cutting the corners easily, if you want the drone to turn quite fast and quickly, you will use more blades, but at the expense of flight time. because it will draw more current. Now, when you select a particular propeller, how will you decide on its size? So whenever you are building a drone and you reach a particular point, when you select motors, you get something called as a motor spec sheet. And on that spec sheet, you will find the different parts that will be compatible with that particular motor. Now, when you are selecting a propeller, you will find 2 digits written on that propeller. For example, on the propeller of 5-inch that I showed you, it has a number of 5045. I've typed it in the chat. So propeller size is mentioned as a 4-digit number. So first 2 digits, that is 50, represents the size, which means that it is a 5-inch propeller. And the second 5 means 4.5 inches. That is the pitch. It, like I said, pitch is the distance that the propeller will travel in one complete rotation. So propeller is the next part in your checklist to build a drone. So do you guys have any questions about propellers or anything you want to share about propellers? Go ahead.
The pitch means how, in what direction?
Can you repeat?
The pitch, the propeller travels is the pitch, but in what direction?
No, pitch is not a direction. Pitch is a distance that the propeller will travel. So imagine, wait, I'll turn on the camera and I'll try to show you. So here, as you can see, this is a propeller. When it spins, it rises up. So if it was not attached to a motor and you would just spin it, it will start flying and it will travel 4.5 inches up. So that is the pitch of the propeller. The direction you are saying is the spin direction, which is the propeller will either be clockwise or counterclockwise. That is a separate thing from the pitch. Pitch is not same as the direction. Direction is either clockwise or counterclockwise. So does that answer the question or?
Yes, sir.
Okay. So there is one question in the chat. So can we use one motor to spin 2 propellers? No, usually when you buy a motor, no, that is specifically built for one motor, one propeller. But there are configurations where you can use 2 motors on one top of the other, creating a coaxial formation that one propeller is on top of the another, but there are actually 2 motors spinning it. The second question is, why does a propeller have a curved shape? Curved shape is mostly because to push the air down. It is just this, it is a similar shape of that of a wing of an aeroplane. So just like the shape of a wing, aeroplane wing, it is curved. Similarly, that propeller is also curved. The shape of the propeller, if you want to know more about it, it was covered in the last session. So why the shape is curved and how the air moves around the propeller. So that you can find in the previous session on YouTube. Okay, any more questions? Or we'll move on to the next part, that is the motor. Okay, so we'll move on to the motors. Now the motor consists of a motor bell and a stator. So motor bell is this outer part which spins. And the motor, to the motor bell, there are a bunch of permanent magnets attached. So as you can see in the picture, the silver blocks here, they are permanent magnets. And the inside part is called as a stator. It has copper windings. So these are actually electromagnets which are powered on and off. And this part, inside part, is called as the stator. It stays static, it doesn't move, while the motor bell is the one that rotates, the outer part. The motors that are normally used in making a drone are called as brushless motors or BLDC motors. I'll type it in the chat. So Ashford is asking whether a propeller can cut a human finger. Yeah, it is possible. If the propeller is big enough, it might actually cut your finger. So the motor is called as a BLDC, that is brushless DC motor. So this particular motor has 3 wires. So as you can see in the picture, there are 3 wires going out of the motor. These 3 wires are connected to a set of electromagnets. That is, these electromagnets attached to the stator. But while a normal DC motor will have 2 wires, that is red and black. And you guys must have used a normal DC motor wherein you connect those red and black wires directly to a battery. And if you reverse the terminals of the battery, the motor will start spinning in the opposite direction. But in this case, you cannot connect any 2 wires to a battery. They don't go to a battery. They go to another part of the drone, that is the electronic speed controller. And through the speed controller, it goes to the battery. The motor spins as a result of turning on and off of the electromagnets. So these electromagnets that you see here, they are turned on and turned off in a particular sequence, which causes the permanent magnets to be attracted towards them, and it causes them to spin. So this is why the motor spins on a drone. These electromagnets are turned on and off very rapidly in a particular sequence. And this, as a result, the motor spins very fast. There are also brushed motors that can be used in a drone. So by brushed motors, I mean the normal ones that you see. But they are generally not used in multi-rotor because brushed motors tend to wear off quite quickly. But they are actually used in smaller drones, like the one I showed you in the beginning, the blue colored one. That one is actually using a brushed motor. So any questions about motors until now? Before we move on to the technical aspects, like how to select a motor and all.
So which motor is more power efficient, brushless or brush motor?
In case of a drone, it is brushless. But sometimes you might need, for other applications, you might need a brushed one. Okay, so let's move on to the technical part of like how to select a motor. Whenever you are building a drone, you should, if you have the purpose of the drone in mind. Okay, Ashford is asking a question, how much kilometers per hour can a motor work? So are you asking about the rotations, I think? How fast a motor can spin? So we'll come to that in the technical aspects of the motor. So before building a drone, if you have the purpose in mind, you should also have a slight idea of how much the drone will weigh, like what will be the end weight of the drone. If you have the slight idea, like approximate idea of how it should weigh, you should be able to find out how much thrust you need to make the drone fly. Once you estimate the weight of the craft, consider all the items that you will be adding on the drone, like sensors, battery, etc. And it is always better to slightly overestimate the weight. To lift a particular drone, for example, if the drone is of 1 kg, then the thrust produced by the motors should be at least 2 kgs, that is double the weight of the drone. So in case of a quadcopter having 4 motors, each motor should produce a thrust of 500 grams. So all 4 motors producing 500 grams will give you an end result of 200 grams, that is 2 kg. So there's a question by Dan, if is there any motor which is small and can spin very fast? So actually small motors spin faster than bigger motors. So it is a particular attribute of the motor that will be coming in the next part. So first, so did you guys understand about the thrust to weight ratio? That the thrust produced by the drone should be at least twice that of the drone weight. So it's a formula used to calculate the thrust required. It's called as thrust to weight ratio. Are there any questions about the thrust to weight ratio?
No, sir.
Okay, so you understood, right? What is thrust to weight?
Yes, sir.
Okay. The first thing you look at is the motor dimension. Just like the propeller, motor dimension is also mentioned as a 4-digit number. Is there a question, or if there are no questions, please unmute yourself.
Sir, what
Yeah.
is the formula for thrust to weight ratio?
Thrust to weight ratio is total thrust required. That is double the motor, double the weight of the drone upon the weight, total thrust upon the weight. That is the thrust to weight ratio.
Thank you.
So this will, the thrust to weight ratio, whatever the answer of that equation is, will determine how fast the drone will be. Any drone having a higher thrust to weight ratio will be quite fast. So for example, this drone I have here, it has a thrust to weight ratio of 10, meaning the thrust produced by it is 10 times more than its weight. Therefore, it is quite fast. While this one is a heavier one. I think this thrust to weight ratio of this one is 4. So that's why it is slower, but the purpose is to be slow because it has guards around the propellers which protect it and the people if it hits something, etc. Okay, so just like a propeller, a motor size is determined using 2 numbers. Whenever you go to buy a motor, you will see something like this, a 4-digit number around a motor saying this motor is 2205. So first 2 digits, 22, is the diameter of the stator in millimeters. And the next 2 digits, that is 05, is the height of the stator in millimeters. So stator is the inside part that we just learned. The part that consists of electromagnets is called as the stator. In this case, a 2205 motor, the 22 will be the diameter of the stator and 05 will be the height of the stator. When you buy a frame, it will be mentioned on the frame that this frame supports a 2205 motor. So from the frame, you can move on to selecting the motor using that particular number. Some frames will support a motor of 1105, that is smaller than a 2205, because in that case, the motor stator will be smaller. A smaller motor will be able to spin smaller propellers. It will not be able to handle bigger ones. Wider the stator, bigger the propeller it can handle because it will be producing more torque. So torque is the spinning action, spinning force that a motor produces. This is why you generally see bigger propellers on bigger drones. Like in case of a pesticide spraying drone, you will see big motors spinning big propellers because they need a large amount of thrust to lift the heavy weight. Now coming to the spinning, that someone was asking how fast a motor can spin. That is determined by a number called as a kV number. kV is 1000 revolutions per volt. So the motor I have has a kV rating of 2300 kV. This will be mentioned again on the motor website wherever you are buying it from, along with the dimensions. So 2300 kV. So it means that if you apply 1 volt to that motor, it will spin 2300 revolutions per minute. Just like that, if you apply 2 volts to the motor, it will spin double the revolutions, that is 4600. If you apply 3 volts, it will be multiplied 3 times, and so on. And someone was asking whether are there any smaller motors that spin very fast? Smaller motors actually tend to have a higher kV. That is, for every volt applied, the smaller motor will spin faster as compared to a bigger motor. This is similar to the tires of a car and a truck. So we have seen that the wheels of a car are smaller and wheels of a truck are bigger, and car has more acceleration because it is smaller and lighter than a truck. But the purpose of car and truck are different. A truck is used to carry heavy loads, while a car is used to transport passengers. And just like that, the wheels of a truck are bigger, hence they spin slower. To complete a full revolution, the wheels of a truck require more time as compared to that of a car. Okay, did you guys get that?
Yes, sir.
Okay, any questions?
No.
Okay. So just like
Sir,
propeller, yeah.
so I have a question.
Yes.
How do you make the lightest drone that can still fly for more than the regular drones, like 1 or 2 hours?
So at the end of the session, I think you should be able to tackle that question yourself. So it'll have a quite a big answer. And like you'll have to analyze the weight, you'll have to select the proper parts according to the weight for like getting the best flight time. Highest
So,
flight
sir,
time, yeah. The highest
if
flight time
we
that I have seen is 40 minutes, I think, up to someone has built that much.
mm, if we use aluminium instead of iron or metallic wood instead of iron, then will it give us longer flight time?
Yeah, because it will be lighter, it will be give you more flight time. And you will usually use carbon fiber rather than aluminium because that is much more lighter.
Thank you, sir.
Okay. So just like propellers, motors are also designed to spin in a particular direction. While motors don't actually, you can actually control the direction of the motor spin. You can make them spin both clockwise and counterclockwise. But the propellers that are attached to the motors, they are attached using a nut. I'll show you that on the video. So the drone I have here, as you can see, this propeller is attached to it using a nut. What happens is when the motor spins, there is a chance that this particular nut might get loosened up and the propeller might come out while it is flying. Therefore, the motor nut is designed to spin in the opposite direction of the motor spin. Therefore, while spinning, it actually gets tightened up. That's why the motor is supposed to be attached in its correct position. If it's a clockwise spinning motor, it has to be attached to a clockwise spinning propeller. If you do the opposite, there is a chance that while spinning, the nut might come out. While some motors like this one, they have 2 screws attached to it. These don't have that issue because there are 2 screws instead of 1 nut. So generally on bigger drones, you will be seeing something like 2 screws rather than a single nut.
Sir, and DJI drones,
Yes, you had a question.
they also have two side propellers.
Two screws, two screws, right? Yeah, that is. Yeah, DJI propellers. Some of the propellers, I think, they are separate blades. It's a single blade, and you have to screw them separately. That is actually done to prevent the propeller from getting loosened up. Rather than using one single nut, you will be using two screws to make them tighter. Okay, so any questions up until now? If not, then we'll move on to the
No,
motor
sir.
spec sheet. So, okay. When you go on to the websites or when you buy a motor, you will find a motor spec sheet under that website. Just like when you buy a phone, there's a list of specs, like how much megapixel the camera is, what is the battery life of that phone. So just like that, when you go to buy a motor, you'll have a spec sheet mentioned under that under the web page of that motor, and there you will find how the motor behaves in particular conditions. I'll be showing you an example of that just in a moment. Okay. So can you guys see the screen? This is a motor spec sheet. Is it visible? Please reply in the chat or
Yes.
okay.
Yes, sir.
Okay, in the motor spec sheet, you will find the dimensions, like how high the motor, what is the height of the motor, what is the height of the top part where the propeller goes, and how the screws are underneath the motor, which you can see here. And in case you are building your own frame, this will help you in designing, like correctly mounting, putting holes on that particular arm to mount the motors. So this is the motor spec sheet. This shows you how the motor will behave in particular condition. The first column in this table is motor type. So this will tell you that this particular motor is a 2205 having 2300 kV. Now we know what these numbers mean. While this RS is just branding, you can ignore that. 2205. So this motor having a width of 22, height of 0.5 and has a kV rating of 2300, which means for every volt it will spin 2300 revolutions per minute. Then we have two sections of that table. The first section, that this part on the top, is the section for when you are applying a voltage of 12 volts to this motor. The second section is for when you're applying 16 volts to that motor. That's why it's mentioned as the voltage. And the third column is the pedal size, which actually means the propeller size. So like we learned previously, this motor will support a propeller of 50-45, that is 5-inch propeller. Then again, this is branding. HQ is branding. Next, as you can see here, current, thrust, power, efficiency, speed. From this, you can actually, like someone was asking how to increase the efficiency and flight time. You can use this table to actually find the efficiency and the flight time that the drone will give you. But since you're building it for the first time, we will not be going into the efficiency part, power part. So two things you will need for now is the current and thrust. So these two columns you will be paying attention to. Now, you considering this motor 2205 2300 kV motor, if you apply 12 volts to it, when it draws 1 amp of current, the thrust you will get is 62 grams. Just like that, when you are applying when it gets 3 amps of current, you will get a thrust of 162. So this is actually the speed of the motor. At the lowest speed, this is the current drawn. and at the highest speed, this is the current drawn. So at the full speed, the motor will be drawing 20.7 amps of current and producing a thrust of 712 grams. So when you are calculating like in the previous section, I told you about the thrust to weight ratio. If you are building a racing drone, you will need a thrust to weight ratio of 8, 10, something like that. By using these thrust readings, you will actually be able to select the correct motor to get the correct thrust to weight ratio. Now, in that calculation, you should actually use a value that is somewhere around the middle, because it will be very unlikely that you will be flying at full speed all the time. So somewhere in the center part, you should consider. So use the maybe 500 grams in your calculation, like we did previously. For a 1 kg drone, each motor should produce at least 500 grams. So we'll have 4 motors producing 500 grams. That is in total 2 kg of thrust. And here you will get the speed of the motor spin. That at this point it will be spinning 6,400 revolutions. And at the maximum speed, it will be spinning 20,000 revolutions per minute. Just like that, if you decide to use a 16-volt battery, these readings were for the 12-volt battery. Now, if you decide to use a 16-volt battery using the same propeller as mentioned here, at full speed, the motor will draw 30 amps of current, that is 29.9, approximately 30, and it will produce a thrust of 1 kg. So one motor will produce a thrust of 1 kg, and consider 4 of these motors. They will produce a thrust of 4 kgs in total. Okay, any questions about the thrust to spec sheet? Because this is the like one of the most important parts when you're building a drone. Because from the spec sheet, you can select the battery voltage. You will know what battery you have to use. You will know which propeller you should use. And also the electronic speed controller that you will be selecting next will be selected depending upon the highest current drawn. So at this stage, after looking at the motor spec sheet, almost half of your parts you'll know how what to buy. In this, the highest number here you should note down. If you'll be using a 12-volt battery, you should remember that the motor will be drawing 20.7 at the maximum speed. If you are using a 16-volt battery, at the max speed, the motor will draw 29.9 amps of current. So these are the readings that you should note down. Any questions up until now? So Deepak is asking whether when speed is less, efficiency is more. So just like in a car, if you're driving at a slower speed, you are still using like a very slow speed, you are driving the car, you're still using quite a bit of fuel. But at somewhere around above 40, you will be getting the highest efficiency in a car. And if you're going even higher than that, the efficiency slowly starts dropping. So just like that, you can apply that principle here, and it is pretty much the same. The more faster you go, the higher the battery will be depleting. Faster the battery will be depleting. That will, the Deepak is asking where will be the maximum efficiency? That will actually depend on the type of drone you are building. It will change from every build. It will not be the same. Any other questions?
So,
Yes.
if you want to buy this motor, which have to go?
To buy the parts, we'll be sharing you all the links where you can buy the parts in India, and also like foreign websites we'll be sharing with you at the end of the session.
Will we have to note it down and you will display it on the screen?
No, I'll share you the file directly. You just have to download it.
Okay, sir.
Yes. Any
Sir,
yes,
sir, is a solar drone possible?
could be possible, but for now it's not, because the current drawn by the mode these, as you can see here, it's 30 amps. It's quite high. So like the draw will be much more faster than the solar will be able to produce. So right now I don't think it is possible.
So we can just put a transformer there.
But you still need to generate that electricity, right?
Hmm.
And if you put something big like that, then it will increase the weight of the drone again. There are many trade-offs like that. If you are putting a bigger battery, that will again increase the weight of the drone, and you will have to spin the motors more to achieve the same speed. So these are the trade-offs. So like someone was asking, where is the maximum efficiency? That is where the efficiency will come into picture. Like what is the sweet spot of the weight, perfect weight and perfect thrust point? Where is that you guys will have to find out when you're building your own drone, like adjusting the weight of the drone by removing some extra pieces like that. Okay, any other questions?
No,
Okay,
sir. No.
so we'll move on to the next part, that is the ESC. ESC stands for electronic speed controller. I'll type it in the chat. So electronic speed controller, as the name suggests, it controls the speed of the motor. Now in the picture above, you can see that there are three solder pads here. So this is where the three motor wires will be connected to. Since the BLDC motor has three wires, this is where it will go, and through the ESC, it is then connected to the battery supply. So these red and black wires you can see here, big ones, these go to the battery power. While the smaller wires that are here, yellow and black, these actually go to the flight controller. And on these two wires, these are called as the signal wires. And on these wires, the speed signals are sent. The flight controller will determine how fast the motor should spin, and it will be communicating that speed on these two wires. And then that command of increasing the speed of the motors will be executed by the ESC. And ESC will be increasing the speed of the motors or decreasing. Okay, like the ESC, here you can see the first thing you should look at is the current rating. In the picture, you can see this particular ESC has a current rating of 30 amperes. And in the previous spec sheet, we saw that the highest current at 16 volts was 29.9. So in that case, you can use this ESC, but it is quite close to 29.9. So this will not be a recommended ESC for that purpose. But if you were using a 12 volt battery, in the previous spec sheet, we saw that at 12 volts, the motor was drawing 20.7 amps. So in that case, you will be able to use this ESC because it is quite higher current rated than the 20 amps. So first thing you should look at when buying an ESC is the current rating. And how do you get the current rating? You get it from the motor spec sheet. The highest current that the motor will draw will be drawn through the ESC, and the ESC should be able to support that current. If not, then the ESC will get burned. The next thing, like if you're using a 12 volt battery, the ESC should be able to support that 12 volt battery. If you're using a 16 volt battery, the ESC should be able to support that 16 volts. If not, then again it can burst or it can get burnt. So the support is shown here, LiPo 3 to 6s. So what this 6, 3 and 6s is, we'll be seeing in the battery section. So 3 actually means 12 volts and 6 means 22 volts. So this will be exploring in the lithium polymer section, that is LiPo means lithium polymer, and those are the type of batteries that are used on the drone. And when selecting a ESC, the current draw, that is the current rating, it should be slightly higher, at least 20% higher than what the motor will draw. In the spec sheet, we found that at 16 volts, the motor is drawing 29.9 amps. Therefore, the ESC should be slightly higher. That is either 32 amps or 5 amps should be enough for that particular motor and voltage. And also the battery. So these are the two things that you should look at when buying an ESC, whether it supports the voltage you're putting or whether the motor is drawing that much current and the ESC should support that current. You will, as you can see in the previous spec sheet, we saw that a higher voltage can produce more thrust. So if the thrust requirement is high, you will be using a higher volt battery. Okay, any questions about the ESCs? Oh, and by the way, when you're building a drone, you will need one ESC for each motor. So in case of a quadcopter, there are 4 motors, you will need 4 ESCs, one for each motor.
So how much does a ESC cost?
That will depend on like the current rating that you can see for yourself when I send you the links now. Okay, so what there's a question is how to control an ESC. The ESC, like I said, these two wires, yellow and black, are the signal wires, and it is controlled through there. And these two wires go to the flight controller. Flight controller will send the signals to the ESC, and then it will translate those commands into motor speed. So you don't have to actually do something to, like, you don't have to code or do something to control that ESC. That is handled by the flight controller. You only have to deal with the flight controller, that is configuring it, and the flight controller will do the rest.
Sir, how does the flight controller control without any coding the speed?
That I will talk about in this flight controller section. Okay, let us keep moving slowly, one part by one part. So there's a question if the ESC can work wirelessly. I'm not sure if it can, because again it draws quite a lot of current, and to transmit that current wirelessly, I'm not actually sure if it is possible. 30 amps of current you'll have to pass, like transmit somehow. Okay, so now we have explored 4 parts. So we start with the frame or the propeller. Then once you select the frame or the propeller, you move on to the motor. And from the motor, you will get the motor spec sheet, which will help you identify the correct battery voltage you need and also the correct ESC that you need. The next thing that comes is the battery itself. Now, in case of a drone, you cannot just select a battery randomly. There is a specific calculation required that will help you in identifying the correct battery that you need. Okay, before we move on to the battery, are there any more questions or shall we move to the next part? Okay, so we'll continue in that case. Thanks, Kenneth. Okay. As we have seen in the motor spec sheet, a multi-rotor requires quite a lot of current to fly because it has to oppose the force of gravity and fly. Therefore, it needs quite a lot of current. And the battery that we use for a drone should be able to supply that current in a very short amount of time. The normal AAA batteries, AA batteries that you use in your remotes and small appliances, they are not useful in a drone. You need a specific battery called as a LiPo battery, LiPo, which is short for lithium polymer. I will type it in the chat. So Dan is asking how much time does it take to build a drone? Okay, it actually depends on your skill. If you're a new person, I think it will take you around a day or 2 days, something like that. For me, I can build it in 5 hours, 3 hours, like depending on how big the drone is. Okay, so lithium polymer battery. Lithium polymer battery can store and supply a high amount of current very quickly, making it suitable to be used in the application for a multi-rotor. Now, before we move on to talking about lithium polymer batteries, so word of safety, lithium polymer batteries must be handled with care. If they get damaged a lot, like if you just throw it around, toss it around, it might damage the battery. And if it gets damaged, they start to swell up. By swelling up, I mean they start to get bigger. Some gas starts to form inside, and which causes it to swell up like a balloon. And therefore, and there's a chance that the battery might break. And when the insides of the battery are exposed to air, there is a chance of the battery bursting into flames. And therefore, it is advisable to be gentle with these batteries. As long as the battery doesn't like open up from its cover, it is safe. Okay. So let's talk about the voltage of a battery. A single lithium polymer cell has a nominal voltage of 3.7 volts. 3.7 volts is the number that the manufacturers use, but this is not actually the maximum capacity of the LiPo battery. The maximum voltage of a LiPo battery is 4.2 volts, and it can go down up to 3.5, 3.3. If more voltage is required, then we connect a multiple number of lithium polymer cells in series to form one battery. And that is why it is called as the S pops up. So like in the previous ESC section, we saw 3S, 4S, 6S. It actually means that 3 lithium polymer cells are connected in series. 6S means 6 lithium polymer cells are connected in series. And when a battery is connected in series, the voltage is increased. Therefore, when a 1S battery is having 3.7 volts, a 2S battery will have 7.4 volts. Similarly, a 3S will have 11.1, 4S will have 14.8, and so on. So the links, Dan is asking if we will be sending the links. So the links, like I said, I'll be sharing a PDF file with you, and in that the links will be mentioned of where you can buy the different parts. And from those websites, if you think that building a drone is difficult, you can like directly purchase a build drone from there. Or you can also ask us to build one for you. So the voltages that what?
You can build for us.
Yes, we can build one for you.
How much? How much?
That I'll talk to you later, not in the section, because this session has a limited time of 4. If we start talking about that, no, it'll go about the mentioned time. Okay, we'll talk about that in the WhatsApp group if you're interested.
So how to log in into the WhatsApp group?
If you don't have the link, then I'll ask my friend to share it in the chat. WhatsApp group link. Okay, you will get it in some time in the link in the chat.
Yes, sir.
Now the voltage that I just said, a single lithium polymer cell has a voltage of 3.7 volts. So multiplying that by 2, you will get 7.4 volts. That is a 2S battery. Okay, so the link is sent by Ravindra on the chat. You can click the link to join the WhatsApp group. Okay, did you guys get it? Okay. While 3.7 is what the manufacturers use, the actual voltage will be 4.2 volts. The highest you can charge the battery is up to 4.2 volts. But when you go to buy a battery, you will usually see the battery voltage mentioned in multiples of 3.7, because that is what the manufacturers prefer to use. And when you go to buy a battery, you will see that this particular battery is either 2S, 3S, 4S. So using that number 4S, you will be able to identify that this battery will be 14 volts or 16 volts, like that. More the number of cells, higher the voltage it will be, and the motor will spin faster. So Keon is asking what is 1S, 2S. So 1S, like I said, 1S means a single lithium polymer battery of 3.7 volts. 2S means two cells connected in series. Like you can see here in the picture, in this 350 mAh battery, there are two cells here, one above the other. These ones are 1S batteries. And here I'll show you one that I have. Like if you look closely, you'll see there are three layers on this battery. So this is actually a 3S battery. Now, whenever you are using a lithium polymer battery, it should be used between 4.2 volts to 3.3. You should actually stop using the battery at 3.5 volts to ensure a longer life of that battery. You can charge it up to 4.2, but stop using it at 3.5 volts. If the battery goes below 3 volts, it can cause the battery some damage. It can cause some permanent damage to the battery, and it might lose its current holding capacity and might not give you 4.2 volts next time. Also, if you are overcharging the battery more than 4.2 volts, it can cause the battery to catch fire. Okay, so before we move on, are there any questions? Or we'll take a break for 5 minutes. Okay, please reply in the chat. Okay, then we'll take a break for 5 minutes. Then yeah, I'll continue about the battery after the break. Okay. So we'll wait for a 5 minutes. You guys can stretch. Then we'll talk about batteries. So Deepak is asking if we can use any other battery than lithium polymer. So one other battery that you can use is called as lithium ion. So they are a good replacement. They are safer as compared to lithium polymer, but manufacturing of lithium ion batteries having a high current discharge rate is difficult. That's why you usually see lithium polymer batteries more.
Sir, excuse me.
Yes.
Are there any drones which have batteries which have high capacity and are very light?
Batteries, you're asking, I think, because of You want to achieve a higher flight time, right? You want to get a higher flight time, right? That is the main
Yes, sir.
purpose of your question. So it is not, it doesn't actually depend fully on the battery. It actually depends on how much current the motors are using. It will depend more on your drone rather than the battery. Like how, if the drone is very heavy and the battery is light, small battery, then it will get over quite quickly. So you should like try to make the drone as light as possible, then you will get a more flight time. Okay, we'll stop for 5 minutes and we'll resume the session after that. Okay. Okay, so we'll resume the session. Before the break, we talked about the battery voltage. So did you guys understand about the battery voltage? One lithium polymer cell will have a voltage of 3.7 volts. If it is two cells connected in series, it is called as a 2S, having 7.4 volts. If there are three cells connected in series, it is called as a 3S, having 11 volts, and so on. Next thing we will look at is the battery capacity. Battery capacity is mentioned in mAh, which stands for milliamp hours. In the picture here, you can see there's a battery of 350 mAh. There's a battery of 300 mAh. There's one here of 1000 mAh. And here it's mentioned 1.5. This actually means 1500 mAh battery. The capacity, when you see a capacity, if it is 1000 mAh, so this 1000 mAh, sorry, it actually means that if you draw 1 ampere of current from the battery in 1 hour, it will drain the battery. Okay, understood? If you are drawing 1 ampere current from a battery having a capacity of 1000 milliamp hours, so it will take 1 hour for that battery to completely drain. Which means if the battery has more capacity, you will have a longer flight time. But a bigger battery also has more weight. This is a trade-off. The next thing is the C rating. C rating, like someone was saying about talking about the discharge of a battery. C rating indicates the maximum discharge rate of the battery. In the picture, okay, I'll show you a battery which is in my hand. Here you can see this is a battery of 450 mAh having a C rating of 65C. 65C. This indicates the maximum rate of discharge the battery supports. We can calculate the exact rate of discharge by multiplying the total capacity of the battery with the C rating. Okay, for example, if the battery is having 12,000 mAh, I'll be typing it in the chat, having 50C. So 12,000 mAh is the capacity of the battery and 50C is the C rating. If we multiply these two values, like 1200 multiplied by 50, you will get this as the answer. So this is in milliamps. If you divide this by 1000, you will get 60 amps. Okay, which means that the total discharge rate of the battery can discharge up to 60 amps of current at one particular point of time. This is the maximum current discharge rate. This will be helpful in identifying the current battery, the correct battery you will need for the drone. Next is the battery connectors. Batteries can have different types of two types of connectors. So there's one white connector. This white one is called as the balance lead. This is used for charging the battery. While this yellow one here is called as the discharge lead. This is used for connecting the battery to the drone. And these are the terminals from where the battery will be discharged. That is, the power will be drawn from here. While this one will be used for charging. Now this is called as a XT30 connector. I'll type it in the chat. XT30. The connector I just now showed you, and the one that you can see here, this is the XT30. A same looking connector, but which is bigger, like this one.
So
This
I
one
can't see.
supports. No, I'm not showing it on the screen. I'm not sharing my video right now. I'm just showing you the picture. Okay, on the left side of the picture, can you see the yellow colored connector?
Yes, sir.
Okay, so that is a slightly bigger connector than what I just showed you. That this is called as a XT60 connector. This one supports more current than the smaller one. This is used on smaller drones, while this is used on bigger drones. There are more bigger connectors called as XT90 and so on. So whatever the connector is on the battery, the opposite connector should be on the drone so that it easily plugs in. I'll show you a pair of connectors here. So on the video screen, you will see this is the connector of the battery and this is the connector on the drone. So it is opposite of what is on the battery and they easily plug in like this. Got it? Yeah, the balance connector is also used for checking the voltage of each individual lithium polymer cell inside a battery. The battery that I showed you a moment ago is a 3S battery, and each lithium polymer cell has its own voltage. Like the maximum voltage will be 4.2. Now, if after flying the drone, if you want to check the battery voltage, you get a battery voltage checker, which is to be plugged inside the white connector, and that will tell you the voltage the battery is at, and it will also tell you the voltage of the every cell inside that lithium polymer battery. Okay, any questions about the battery? The next part will
So,
go, yeah.
how much does a 1000 mAh with 10-volt battery weight?
1000 mAh 2S, you are talking about 10 volts meaning 2S battery. 1000 mAh 2S battery. I'm not exactly sure, but it will be, I think, around 50 to 100 grams, somewhere in that range.
So it's unlikely to put in a small drone, right?
Yeah, it will go in an intermediate drone, not too big, not too small. The
Yes,
small,
sir.
the battery I showed you, the blue colored one, it is around 20 grams.
And it will
That
give
goes in small.
around a half an hour time to fly.
That will depend on the drone. Like I said previously, the flight time actually depends more on how you use the drone, how the battery is, how the drone is built, how much current it draws, and not actually fully dependent on the battery.
Yes, sir. Thank you, sir.
Okay. Keon is asking what can we do if the wire of the battery comes out. So you can actually try to repair it, but if not, then you should not attempt to open the battery up. If you're not an expert in the opening batteries and because like I said previously, if you don't handle the battery with care, then there's a chance that it might burst. It might catch flames and all. Okay, so we'll move on to how to select the correct battery for a particular drone. In the previous example, let's consider that we have a quadcopter, and in the spec sheet we saw that at 16 volt a particular motor was taking 29.9 amps, which is approximately 30 amps. So in a quadcopter we have four motors, and at the max point, the each motor will draw 30 amps of current. So one motor will draw 30 amps of current, but there are four motors that will draw 30 amps of current, which means 4 multiplied by 30, you will get 120 amps. This is the maximum requirement of your drone. So from the motor spec sheet, we found out the current drawing capacity of the drone. 120 amps will be the maximum current required by the drone. And this is the capacity, this is the current required. So this is the 4 multiplied by 30. which is 120 amps. And this is the current requirement when you are at the highest throttle point, which means you're driving the drone at full speed. So in reality, the actual current draw is going to be lower than what is mentioned in the spec sheet, because the tests are done on a bench and not actual drone. And also consider the fact that you are not going to fly at 100% speed all the time. So normally you will be flying at around 40% or 80%, 40 to 80%, somewhere around that range, and not actually 100%.
Even
Okay.
even for mobile phones, they don't give the actual capacity of the battery.
Yeah, mobile phones, they actually mentioned it in MEH, I think, similar to
Yes.
lithium polymer.
But the actual capacity is lesser than that what is mentioned.
Okay. So there's a question. Someone is asking, Pratham is asking, will it have the same connector for the drone and the charger? Yes, the drone, it will not have the same connector. It will have a opposite connector. So the connectors are of two types, male and female. So they plug into each other. If the battery is having a female connector, the drone will have a male connector. Just like that, if the battery is having a male connector, the charger will have a female connector. If they are both the same, then it will not be plugging. You will not be able to plug it in. Okay, coming back to our calculations. So one motor requires 30 amps of current. So this is an example. In this example, we are taking that one motor requires 30 amps of current. And there are 4 motors in a quadcopter. So 4 multiplied by 30 amps, we get 120 amps. This is your maximum current requirement of the drone. Therefore, the battery that you will buy should be able to at least give you this much, 120 amps. It can be more, but it should be able to do 120 amps. You can actually select a lesser like discharge rate battery because you won't be flying at 100% speed. Like I said, this is the current draw at 100% speed. So you won't actually be flying at 100% speed all the time. Next, you also saw this is one formula. This is the formula to calculate the current draw of the drone. That is the number of motors multiplied by the maximum current required by a single motor. So in our case, it was 4 multiplied by 30. So Dan is asking if we can use phone batteries to fly a drone. Well, like I said previously, LiPo batteries, lithium polymer batteries have the special property that they can give a large amount of current in a short amount of time. So since the phone batteries, I don't think will be able to supply that much current in a short amount of time.
Sir,
Yes.
sir, this drone needs 150 amps, no, 120 amps, right?
Yeah, the example drone which we are using, since there are 4 motors and one motor is taking in 30 amps of current, right? So multiplying that, the drone will be requiring 120 amps of current, maximum 120 amps.
Sir, but if a fridge is only have like 15 amps, so why does this need so much?
No, that is because it has its application, right? Fridge, it has its application that it should oppose the force of gravity and pull itself up. Therefore, it uses that much force. While any other appliance won't be, it's not physically moving, right? It just stays on one particular point and does its function.
Okay, sir, thank you.
Okay. So using this formula, you can calculate the current requirement of your drone. Next, we have already seen how to calculate the current requirement of the battery. So we calculate the current requirement of the battery by multiplying the total capacity in mAh. So capacity in mAh multiplied by the C rating. So in our case, we will require a battery that should be able to give 120 amps of current. So for this example, we'll take a battery having 1600 mAh, having a C rating of 90. So this will give us 144 milliamps, which is 144 amps. So this battery will be able to support that particular drone. So did you guys understand that? How to calculate the maximum battery output and what the drone requires?
Yes, sir.
Okay, any questions?
No.
So what is a C?
C is the maximum discharge rating. You will see that on the battery. So here on this battery, can you see it's written 65 C? Is it visible?
Yes, sir.
Okay. So just like that, you will find it on other batteries also.
What does it mean, sir?
It is the like maximum. It tells you the maximum current it can give out at a particular point.
Thank you, sir.
Like discharge rate, it's called. Okay, when you buy the battery, also consider the weight of the battery. The bigger the battery, you might think that a bigger battery will give you more amps of current, but it will also add to the weight of the craft. So while selecting a battery, you can either opt for choosing a higher capacity battery or a battery having higher C rating. So both of these will increase your current, the battery current draw. So for small drones, you will need batteries of 450 mAh. Like any drone that is under 250 grams, you'll be using batteries that are 450 mAh or 500 mAh or 650 mAh. Big drones will require 1000 mAh battery or 2000 mAh. In extremely big ones like the spraying drone that we have that uses a 10,000 mAh battery.
And 20,000
That will be for even bigger drone.
heavy duty.
Yeah, heavy duty. What you remember from the last session.
So what happens if we use 20,000 mAh battery for a small drone?
20,000 mAh battery will weigh only about 2 kgs. 2 to 3 kgs it might weigh the weight, while your small drone will be just few hundred grams and it will not be able to lift only.
Sir, what about the drones which uses cameras? How much for that?
When I told you know about any drone under 250 grams, you can actually fit a camera on any drone. FPV camera. So we'll actually be talking about that FPV camera, FPV system in the next session. Like how to attach a camera there, how to transmit the camera feed to the ground.
Okay, sir.
Okay, so on the drone, other than the motors, there are also other components like there's an LED, there might be a LED there. There might be a sensors like GPS. Then why did we only consider the motors? Like someone was asking, like how come a drone is drawing more power than a fridge? So this is similar, just like that. We don't consider the other components because the current that they draw is quite negligible. It is very small as compared to what the motors are drawing. Therefore, you can ignore them during the battery calculations. And the charging of the batteries. The battery chargers that you get actually allow you to increase the or decrease the current at which the battery can be charged. Like I said, 1000 mAh battery can be discharged in 1 hour if you are drawing 1 amp of current. Just like that, if you are putting in 1 amp of current, you can charge that 1000 mAh of battery in 1 hour. So it is called as 1C. The battery, let's say the 16,000 mAh battery, which we took the example of, the charging current for that should be 1.6 amps. So therefore, it will take 1 hour to charge that battery. It is called as charging the battery at 1C. So for any battery that is charged at 1C, it will take 1 hour to charge that battery. So theoretically, if you increase the current output from the charger, if you are charging the battery at 2C, it will take half an hour to charge the battery. And so on. Like you can increase it to 3C and it will be charged in maybe 15 minutes. But the more the current output from the charger you increase, it can be damaging to the battery. And for a longer battery life, it is recommended to charge at 1C. You can go to 2C if the manufacturer of the battery can says that it supports charging at 2C. Then only you can move on to charging the battery at 2C. And the chargers also have a feature which stop the battery from overcharging. So once it reaches 4.2 volts, the charger will stop. But it is always a good idea to have a keep an eye on the battery while it is charging. So, and if you are not using the batteries for a long time, you should keep the battery voltage at 3.8 or 3.7 volts. Leaving the battery at full voltage and not using it for a long time can also be damaging. So if you know that you won't be using it, keep the battery at 3.8 volts per cell. And in case of a fire, if in any case, if there is a fire, don't use water because it is an electrical fire. You have to use a fire extinguisher in that case. Okay, any questions?
What if we use water on electrical fire?
In that water, you might get a shock from that. No, since it's electrical, this you might actually worsen the damage more. Okay, any questions about the batteries? So did you guys understand the formula that I gave to calculate the current draw of the drone and the discharge rate of the battery? Any questions about that? Please reply in the chat if you have any doubts, questions. Okay. So next we'll look at the flight controller. So Deepak is asking, what if there is no fire extinguisher? And then it's your responsibility to get the fire extinguisher with the drone if you are expecting the battery to burst. Normally it won't burst if the battery is new. It only bursts if you are damaged the battery a lot and it has swelled up. You can actually make out just by looking at the battery. A normal battery will be it'll be like this. As you can see, it is a flat rectangular battery. A damaged battery might be oval shaped like this. It might be like a balloon it will be. And if you press it, you'll find it that it's squishy. And that sort of a battery can actually burst if it gets opened and exposed to air. Okay, so we'll move on to the flight controller. This will be the last part of today's session. Okay, so flight controller, or in short, FC. I'm typing it in the chat. FC, flight controller. It is the brain of the multirotor. It takes the instructions from the pilot. The pilot will be transmitting the instructions from a remote, and the flight controller will be receiving those instructions. Then the flight controller will translate those commands into movements that the drone has to perform. Flight controller is responsible for keeping the drone stable in windy environments. A smart flight controller can fly the drone without any human intervention with the help of various sensors. So a flight controller has many sensors, the most common being a gyroscope, accelerometer. A drone can fly with only the gyroscope, but that would be a manual flight. The racing drones that you see, that they don't have many sensors on it because they are manually driven. They only have a gyroscope. The lesser the sensors that you find in a flight controller, the more difficult it will be for the pilot to fly it, because more decisions will be made by the pilot. More sensors used by the flight controller, it means the flight experience will be easier for the pilot, because in that case the drone will be much more smarter. It will have a compass GPS for it to identify the height, the location that it is at, and then the flight controller will be using those sensors, it will control the drone. And in cases where the flight controller has a GPS, compass, barometer, all these sensors, you can just ask the drone, you can give the drone a path, and using all these sensors, the flight controller will actually fly the drone without any pilot. Now we'll look at some of the sensors, some of the common sensors and how they work. So the first one that we will look at is the gyroscope. A gyroscope is the minimum required sensor for a drone to fly. Like I said previously, if it has only a gyroscope, then it will be quite a difficult flight to maneuver for the pilot, because much of the decisions will be done by the pilot and not the flight controller. So in here, as you can see, this drone is not having many sensors. If I am flying this with a gyroscope, what the gyroscope does, it detects the change in angular velocity. What does that mean? So for example, if I'm flying the drone like this and I suddenly give it a tilt, so this is the change in angular velocity. From this flat angle, it went to this angle. So this is the readings that the gyroscope will give in all directions. So it might be this way or this way, towards the left, right, up, down, whichever direction the drone rotates, the gyroscope will pick that up and give it to the flight controller. So this is the job of the flight controller, to measure angular velocity. The next sensor we will be seeing is the accelerometer. It helps the drone to stay flat. So for example, if you guys have used a DJI drone, when you let go of the controls, you'll see that the drone just stops and stays flat. So just like that, drones having an accelerometer, if you stop giving any commands, they will, if they are tilted, they will automatically become flat if no commands are given. This is done using the accelerometer. Accelerometer detects the force of gravity. Accelerometer is also present in your mobile phones. So whenever you're holding the phone in a landscape position, it will automatically detect that the phone is in landscape position and the display will change to landscape. If you hold it straight, it will go into portrait mode. Just like that, in a drone, it will detect the force of gravity and it will level the drone when you don't give any controls. So as you can see, without the gyroscope, it won't be doing that. Without the accelerometer, it won't be doing that. With the accelerometer, it will start stabilizing itself. Next is the barometer. Okay, I switched off the video just now. So the next sensor is the barometer. Barometer detects the height at which the drone is flying. It works by detecting the changes in air pressure. As we know, the air pressure reduces as the height and altitude increases. So this is how the barometer knows how high the drone is flying at. Now, the more that the sensors we are adding, so you guys will notice that more information the flight controller is getting. Starting from the gyroscope, angular change in velocity. Next, we are telling the flight controller by adding an accelerometer where the gravity is. We are telling the flight controller which is the down direction. Next, we are adding the barometer. Barometer detects the height. Now the flight controller also knows how high the drone is. Next is the compass. We all know what the compass is used for. It is used to identify the direction, that geographical north. And hence the flight controller will now know which way the drone is facing. The next most common sensor is the GPS, the global positioning system. It gives the geographic location of the drone. As long as it is in an open area, the GPS will pick up the signal, and now the flight controller will also know where the drone is at. So with all these sensors, the drone will be able to fly on itself. Because it has the GPS, it knows where the drone is. You just have to give it two locations, point A and point B. Then using the geographic coordinates of those 2 points, the drone will fly from point A to point B. The direction will be maintained using the compass, height will be maintained using the barometer, and the turning actions will be maintained using both gyroscope and accelerometer. And like this, the flight controller translates the different commands. Whenever the drone requires to turn, the flight controller will calculate everything. It will communicate that to the ESC and hence reflect the changes in motor speed, causing the drone to turn left, right, move faster or slower, whatever the requirement may be. Okay, any questions about the flight controller?
Sir, how does the GPS work?
GPS is like an antenna. So it directly communicates with a satellite in space. If you're inside a building, you will find it difficult to get a GPS signal. But you're flying outside in open, you will quickly get a GPS signal from the satellite.
So, what is the weight of a flight controller?
Flight controller for bigger drones will be maybe around 20 grams, while the flight controller I have on this small drone, I think it is just 2-3 grams. I think it's just one single chip inside.
And what is the size of a FC?
Again, it depends on the application. The one I just now showed you, this is a 16 by 16 mm 16 by 16 mm flight controller board, while the bigger drones have I think the one in the picture here that you can see, it is around 5 centimeters long. There are also 30 by 30 flight controllers available. One thing about the flight controllers is, like here, as you can see in the picture, can you see these two chips inside, one at the bottom and one on the top? Is it visible?
Yes, sir.
Okay, so bottom, the chip on the bottom is actually the ESC. So this here is a 4-in-1 ESC, which means that all the 4 ESCs that I talked about previously, that one motor will require one ESC. Here, all 4 ESCs are on one single chip. So as you can see, every motor is connected to that chip. The bottom motor goes here, top motor goes here, this one goes here and here. So all the 4 motors are connected to that 4-in-1 ESC. This is actually used on racing drones because it requires lesser space. And on top of that ESC, the second chip is the flight controller. And together this is called as a flight stack. So these flight stacks are used to make the building of drone easier because they occupy lesser space. And you can buy them together actually. Yes, someone had
So
a
the
question.
drone is going like the
Can you
is
type the
going like
question? I'm not able to hear you. Please type the question. Your voice was breaking. Keon is asking whether it is possible to build a drone less than 5,000. I'm not sure, but there are drones that you can directly buy which are under 5K. If you manage to find a drone which you are able to buy under 5,000, and you can look at the parts of that drone and you can buy the same parts and build it for yourself. Yes, I'll be sharing the list of sellers in a moment. Okay, so this is the flight controller is the last part of today's session. And the next time we'll be looking at the transmission of controls, the FPV system, and assembling the parts. We'll also be looking at the different uh, softwares that go on the drone, on the flight controller. So someone was asking a moment ago, like how the flight controller works without any coding. It is because some people have already done the coding for you. You just have to take that software and put it on the flight controller. All you have to do is configure the sensors, connect the parts properly, and you're done. Okay, so I'll share the file with you. I have added the file in the chat. Please find it. It's called drone building checklist. It has the list of all parts of the drone, also the different sellers in India, and also sellers outside India. This is the same file that I had shared last time. If you guys were there last time, you should have this file. Yes, I can share it in the WhatsApp group. Okay, any questions?
Sir, how to join a WhatsApp group?
WhatsApp group link we had shared on the chat. Do you want the link again?
Yes, sir.
Okay, Dan has shared the link that I had shared previously. So you guys can use that link to download the checklist. Thanks, Dan. Okay, this is the link to the WhatsApp group. You can find it in the chat. It is shared by Ravindra. Kion, please put the links in the WhatsApp group. Don't put them here at the moment because your links are quite big and some people might not be able to find the WhatsApp link. Okay, so this was the last part of the session today. Yes. If you guys have any questions, you can ask now. The parts we started with the frame, then we went to the propellers, motors. From the motor spec sheet, we found out what ESCs we need, what batteries we need, and then we looked at the different types of flight controllers. There are some flight controllers that are useful for racing, and there are some that are having other sensors like GPS, compass, which are used in autonomous drones. We also saw the flight stack, which consists of a 4-in-1 ESC, and also it has a flight controller on top. Okay, so I would hand over the session to Goa State Innovation Council.
Yeah, Akshay, thank you for the session. If we do we have any questions? Also, what I'll do, in a minute or so, I'm also going to put the link. Just give me a minute. Okay. So if you check in the chat, you'll find the link of a WhatsApp group. That is nothing but the community of the drone aviation that we have made. So you're free to join the group. Okay. Also, you can share the invite to your other friends who are also interested in drone aviation. So if you do not have any questions, then we can end the session. Thank you so much, Akshay, and the entire team of Pulavan for the wonderful session today.